what I wanted to do today is section. I want to look into section 11.5. That's on what we call the alternating series test. So alternating series. So what is an alternating series? Well, some examples of alternating series are the following. If I have the series 1 minus half plus 1/3 minus 1/4 plus 1/5 minus 1/6 ... Can someone give me a formula for the nth term? What would be the formula for the nth term? What would be the nth term without worrying about the sign? What's the nth term? 1 over n. Now, is it plus or minus? Well, we don't know. It depends on whether, the first one is 1, right? So when n is 1, you got a positive, right? When n is 2, you got a negative. When n is 3, you got a positive, right? So whenever n is even, you're getting what? Negative. Whenever n is odd. So how do I express it here? Well, all I have to do is multiply by a negative 1 to the exponent n minus 1 here. Am I making sense? See, what it does is that when n is 1, you are getting minus 1 to the 0, which is positive 1. When n is 2, you get minus 1 to the 2 minus 1, which is negative 1, right? So this minus 1 to the n minus 1 is keeping track of this alternating signs, right? So how do I write it in summation notation? Well, this would be n going from 1 to infinity, negative 1 to the n minus 1 multiplied by 1 over n. Okay, that's how I can express it in summation notation. So this is an example of an alternating series. So what is an alternating series? Well, it's a series where the terms the signs are alternating, basically. The signs of the terms are alternating. So it's a series of terms with alternating signs. Let me give you another example. Let's say I have the series. I'm going to start with the summation notation. N is going from 1 to infinity, negative 1 to the n, and 1 n over n squared plus 1. So what is that? This is the first term now is what? Negative. So it's, the first term is in the denominator all I want is n plus 1. Okay, so this is going to be negative 1 over 2, right? Plus the second one would be 2/3. The next one would be what? 3/4. The next one would be 4/5 minus ... So you see the idea. My question to you, which of this do you think is a convergent series and which one is a divergent series? Which one do you think is convergent? Yes. First one. Why do you think that's the case? Remember, if I don't have this minus 1 to the n minus 1, if it is not alternating, then the series is convergent or divergent? Divergent. Why? Harmonic. Remember, if the signs are not alternating, is the harmonic series, it is divergent. what you're trying to say is that the terms are going to 0, right? The terms go to 0. That doesn't mean that the series is convergent, right? When the limit of the sequence of terms is 0, doesn't mean the series is convergent, right? And that was my counterexample. The harmonic series is not convergent, it's divergent. However, when you put -1, when you alternate the signs, though, it becomes convergent. Okay, so your answer is correct, it's convergent, but we'll see pretty soon why. The second one. Is the second one convergent or divergent? Divergent, why?
Because every positive term is even bigger than the negative term.
Every positive term is bigger. That doesn't mean it doesn't converge. Yeah, I mean, what you're saying is that...
Like, the 2/3 is bigger. Like,
I see. So you're saying the positive terms are bigger than the negative terms,
so
and that's why...
continually adding.
Yeah, more and more you feel like that, but that's... I mean, if I use your argument, then I could say that if I have the series 1/n squared, right? 1 plus 1/2 squared, 1/3 squared, and so on, we are adding more and more positive terms, but it does converge, right?
Yeah. Well, I'm saying that if you take like every two terms.
Yeah, go ahead.
And the positive terms are getting bigger while the negative terms are getting smaller.
Yeah, it still, that doesn't mean... It still doesn't. So here's what I'm going to say. If suppose you have the nth partial sum, right? What is the sum of a series? The sum of a series, let's say I have an. The sum of a series is the limit of the nth partial sum, right? The sum of a series is the nth partial sum. So maybe I have an nth partial sum where the nth partial sum is increasing, but that doesn't mean it doesn't converge. Because if you have a sequence which is increasing, it might be bounded, and then it has to converge. Am I making sense? So that reasoning itself is not enough to say that it doesn't converge. But there is something we did in the class that says, well, let's just say you should be able to answer this question in the exam that you took. if I ask that question, yeah.
Isn't when you divide all of the exponents of n, then eliminate it and find the limit that way? I can't really explain what I'm doing.
You're talking about the
Do
limit?
you find it's constant or whatever
You're taking the limit of this guy? Is that it?
Yes, but there's... Is it?
So it's not a geometric series.
You can do that.
It's not a geometric series. Anyone else? Yeah.
If you break it down like the first one, n over n plus 1 is
Okay, so what you're saying is that if I look into the limit of the nth term of the series, which is n over, I'm sorry, let me write -1 to the n times n over n plus 1. If I look at the limit of the nth term, remember, if a series is convergent, then the nth term must go to 0. Therefore, if the nth term does not go to 0, the series is divergent. If the limit of the nth term is not 0, the series is divergent. That's the test for divergence. So what is this limit here? What is this limit? Without the -1 to the n, what's the limit? 1. What's the limit with the -1 to the n? Doesn't exist. Why? Because when you say without the -1, the limit is 1, it means that the value of n over n plus 1 is getting closer and closer to 1. But because you have -1 to the n, it's alternating, right? So values are getting closer and closer to 1 and -1, right? So it's not converging to a number. So this limit doesn't even exist. And let alone it's not equal to 0. That's what we care. We care that this is not 0. And by the test for divergence, the series negative 1 to the n over n plus 1 is divergent. Everybody's okay with that. What is my point? My point is I have two alternating series here, right? The first one I said is convergent. The second one I said divergent. So just because you have an alternating series doesn't mean it is always convergent or always divergent. There are some alternating series which are convergent. There are some which are not convergent. Right? Now the question is, now I need to address why the first series is convergent. Why is the first series convergent? And the answer is a little bit complicated to answer, but I will try my best to explain what's going on there, okay? So first of all, let's say, okay, this is called the alternating series test, okay? This is called the alternating series test. This is a test to determine whether a given alternating series is convergent. So generally, how do I express an alternating series? Well, generally, we can express an alternating series in the following way. Consider the alternating series, which is given by the sum n going from 1 to infinity, negative 1 to the n minus 1 times bn, where bn is non-negative for all n. So an alternating series always looks like this, right? You have negative 1 to the n, which is keeping track of the alternating signs, and then multiplied by a positive term, like 1 over n, right? So in my first example, what is bn? So in our first example, bn was what? 1 over n, right? You guys understand what I'm saying? Okay. So I have an alternating series. Let's make two assumptions, okay? Two assumptions that I want to make about Bn. First of all, Bn is a decreasing sequence. Bn is a decreasing sequence. What does it mean? It means that the any term is less than the previous, right? Am I making sense? So it means that Bn plus 1 is smaller than Bn for all n. For all n larger than or equal to 1. Okay? What does it mean? It means that B1 is larger than B2, larger than B3, larger than or equal to Bn, Bn plus 1. Am I making sense? It's a decreasing sequence. So that's my first assumption. My second assumption is that if I look at my second assumption is that Bn converges to 0 as n goes to infinity. So the limit of Bn is 0. It turns out that whenever you have an alternating series where the terms are decreasing in size and the limit of the nth term, the terms are going to 0, then that series must be convergent, okay? If these two assumptions if these two assumptions are met, then the series which is the negative 1 to the n minus 1 times bn, n going from 1 to infinity, then the series is convergent. Okay? If these two conditions are met, then the alternating series is convergent. Is everyone clear on what I'm saying here? What is the test? It is a test to determine whether an alternating series is convergent. So if you are given an alternating series, what do you have to check? You have to check that the limit of the terms is 0 and the terms are decreasing, right? If those two conditions are met, you know that the series is convergent. If one of them is not met, then you cannot say anything. Okay? So here's what I want to say. Here I have one condition. I'm saying the sequence Bn is decreasing for all n greater than or equal to 1. So I'm saying B1 is bigger than B2 is bigger than B3 and so on. But the sequence doesn't have to, the sequence may not be decreasing from the beginning. Maybe it decreases after the 10th term. So maybe after the 10th term, the sequence is decreasing, okay? So it doesn't matter what happens to the first few terms. As long as after some point on, the sequence is decreasing, we are good. Just like in the integral test. Remember in the integral test, I stated that the function f needs to be decreasing, but then I said it has to be decreasing after some point. Another condition that, well, that's the only condition, Another condition is, at this place I said here, BNs are all positive. So you might not have so maybe the first say 10 terms are all positive. But after the 10th term, the series becomes alternating. So I can still consider that as an alternating series. Am I making sense? So the first few terms don't dictate the convergence, okay? Which makes sense. So keep that in mind. Let's do an example to see how these are used. So let's say I have the following series. The series looks like n going from 1 to infinity, negative 1 to the n minus 1, and then 1 over n plus 1. Is this series convergent? First of all, is it alternating? Yes, so I can use the alternating series test. So what do I have to answer here? I have to check two things. I have to check, let's call this guy Bn, right? So let's let Bn to be 1 over n plus 1. And I have to check that Bn is what? Check 1, that Bn is decreasing. That means I have to show what? The n plus first term is always less than the nth term for any n, right? N plus first term is always less than the nth term for any n. In other words, you have to check that B1 is larger than B2, is larger than B3, is larger than ... right? And then the second thing I have to check is that the limit of Bn is what? 0. Well, let's check the first one. Is the first one correct? Well, what is Bn plus 1? Bn plus 1 is what? 1 over n plus 2. Can I say that it is less than 1 over n plus 1? and 1 over n plus 1 is Bn, which definitely I can see that that's true. So 1 is true. So 1 holds. You can also check the following. What is B1? You realize that B1 is half, B2 is 1/3, B3 is. So it's clear that it's a decreasing sequence, right? It's a decreasing sequence. All right. How about 2? What's the limit of 1 over n plus 1 as n goes to infinity? Well, that's clearly 0 because the denominator is going to infinity, while the numerator is always 1. So both conditions are satisfied. So 2 holds. And therefore, I could say by the alternating series test, the series sum minus 1 to the n minus 1, 1 over n squared plus, 1 over n plus 1, and going from 1 to infinity is convergent. Is everyone okay with that? All right. Let's do one more example. Say it again. Go back.
Just like the bottom.
Oh yeah. The second example that I want to do is very similar. Just remember when I stated my test, I took the series n going from 1 to infinity, negative 1 to the n minus 1 times Bn. The way I wrote it, my alternating series starts with a positive term, right? B1 is a positive term. But you don't have to start with a positive term. You can start with a negative term. Still, the same test applies. So if I have, for example, the series n going from 1 to infinity, negative 1 to the n, 1 over n squared plus 1, okay, is this series convergent? Well, it is alternating for sure. And then number 1, if I call this Bn, then clearly I will have Bn plus 1 to be what? Bn plus 1 would be 1 over n plus 1 squared plus 1, right? Which is less than 1 over n squared plus 1 because the denominator on the left is bigger. And this is equal to Bn, right? So this is for all n, larger or equal to 1. As long as this inequality holds for all n after some point, that's fine. So it doesn't have to be for all n larger than 1, it could be for all n larger than 3. Okay? And number 2, what's the limit? Well, limit in this case is just as easy. The limit is 0. So the test applies. So by the alternating series test, the given series negative 1 to the n, 1 over n squared plus 1 is convergent. Are we okay with that? 1 to infinity. Everybody understands what's the test? Everybody gets how to apply the test? Okay. What I want to do now is do the difficult part, which is I want to explain to you why, when those two conditions are met, why does the series converge? Okay? If you want to take a nap, if you don't care about this type of things, go ahead. But if you care about that, especially Michelle should, you cannot close your eyes. If you are in math, you can't. But yeah, go ahead. Yeah.
Do you have to find like b to the n plus 1?
B. This is one way of, so if you want to show that a sequence is decreasing, you have to show that n plus first is always less than nth. The n plus first term is always less than the nth term to show that it's a decreasing. There is another way of showing that a sequence is decreasing. I am going to do one more example at the end where I'm not going to use inequalities directly like this. I am going to, so another way of doing this is that if I look at Bn, right, I can think of a corresponding function which is f of x is 1 over x squared plus 1, and then I can find out where this function is decreasing. Take the derivative, find where the derivative is negative. That's going to tell you where the derivative is decreasing. So show that the derivative is decreasing after the function f is decreasing after some point on. Am I making sense? I'm going to do an example like that in a bit. So this is not the only way of showing that the sequence is decreasing. This is a direct way of showing the sequence is decreasing. So if I have something simple like 1 over n plus 1, 1 over n squared plus 1, I usually show that the sequence is decreasing directly. But if my function is, say, complicated like log n over n, then I would use the function f and then show that it's decreasing. Am I making sense? So, all right. So let me try to explain why the two conditions imply that the series is convergent. Here's again. I have the alternating series, which looks like this. We are assuming here that Bn is a positive sequence. So the series looks like the following. Starts with a positive term b1, and then subtracts b2, and then adds b3, and then subtracts b4, adds b5, subtracts b6, and so on, right? Notice that each time you are adding and subtracting something smaller. Okay? All right, so here's what I want to make a picture. So everything will be explained through a picture. And let me pick another axis here. Oops. Okay. So what I want to do is first of all draw. I'm going to plot the partial sums on the x-axis. Partial sums. So I am going to sketch plots S1, S2. Remember, the sum of a series is defined to be what? It's the limit of the partial sums, right? S1, S2. So what is S1? S1 is you are adding one term, right? So S1 is basically the same as what? S1 is equal to what? S1 is equal to what? Let's say this length here is B1, okay? So if I call this length B1, isn't that the same as the value of S1? So S1, I'm going to plot it on the x-axis. S1 is the same as B1, right? Okay, what is S2? S2 is B1 minus, S2 is the sum of the first two terms, right? It's B1 minus B2. So I'm going to subtract now. So how do I subtract B2 from B1? Well, I'm going to start B1 from this side. Whoops. I'm going to start B1 from this side. Sorry, B2. So remember, B2 is smaller than B1, right, in size? So I'm not going to go all the way. I'll be stopping somewhere like this. So that's the length of B2. So what is B1 minus B2? B1 minus B2 is the gap right here, right? So that's my S2. Because S2 is the sum of the first two terms. Okay, how do I get S3 now? Well, I go back from here. How long do I go? Well, I don't go equal to B2 because B3 is smaller than B2. So I stop somewhere here, and that's my B3. Okay, so I'm going to call that my S3. So that's the third partial sum. I'm going to do it a couple of times here. So you'll see a pattern going on right there. So this is my, let's say, B4. So I am getting S4 right about here. And if I go back by B5, so let's say this is B5, I am getting now what? S5. Let me do it one more time. So I get B6, and then this would be S6. Okay, so does anyone see what's going on here? B1, and then I'm subtracting B2, and then I'm adding B3, B4, and so on. What's happening to the partial sums? The partial sums with the odd index, right? Let me call them just. Let me use some. Well, I want to say that the partial sums with the odd indices, I'm going to call them odd partial sums, even though that's a bad way of saying that. So the odd partial sums are decreasing. S1, S2, S3. The even partial sums, the partial sums with even indices, is increasing, right? So what's happening is that the even partial sums are increasing, the odd partial sums are decreasing, right? The even partial sums are increasing, odd partial sums are decreasing. Now, even partial sums are the sequence of even partial sums. Is that sequence bounded? It is, because every even partial sum is less than every odd partial sum, right? So all the even partial sums are less than S1, right? In fact, all the partial sums are less than S1, right? In fact, every partial sum is less than B1, right? Why is that? You started with B1, and then you subtracted something smaller, then you added something smaller, right? So whatever sum you're getting, it's always less than what? B1. So this is bounded. So because you have a increasing sequence of partial sums, it is bounded above. The sequence of even partial sums will converge to some number S. Okay? They will converge to some number S. Same way, the sequence of odd partial sums, they will converge to some number S prime. Okay? Now, S will be definitely less than or equal to S prime because, like I said, even partial sums are always smaller than the odd partial sums. The question is, are they equal? If they are equal, then I can say that the limit of the sequence of all partial sums is the same. So the question is S and S prime are the same. So what am I calling S? Remember, S is the limit of the even partial sums, so S to n going to infinity. And I am calling S prime to be the limit as n going to infinity of the odd partial sums, right? Odd partial sums. And what can I say? Are they the same? Well, let's see. S prime, that's the limit of S2n plus 1. I'm not going to write the infinity anymore. And what can I say about S2n plus 1? Can I say that S2n plus 1 is the same as S2n plus what? S2n is the sum of the first 2n terms. S2n plus 1 is the sum of the first 2n plus 1 terms. So with S2n, what should I be adding? the next term, right? 2n plus first term. What is that? Well, the 2n plus first term is given by b 2n plus 1, right? However, there is a negative or positive depending on what? What would be the exponent on negative 1? It will be, we took our series this way, right? Negative 1 to the n minus 1 bn. So whatever the index for b is, the exponent on negative 1 is 1 less, right? Everybody's okay with that? So the exponent here would be 1 less. Are we okay with that? You guys see that or not? So that's that's this positive one, right? Did that make sense? It's like saying that what is S7? If I ask you what is S7, what did you say? S7 is S6, right? Plus the next term. The next term is what? B7. But what's the sign for B7? It's negative 1 to the 6 here, right? Everybody's okay? So now I could say that I have to take the limit of that. Well, that's the same as taking the limit of S2n plus the limit of b2n plus 1, right? Because negative 1 to the 2n is positive 1. So we know that the limit of S2n is assumed to be S. And the limit of b2n plus 1 is what? My second assumption was what? In the alternating series test, bn converges to 0. So the limit of b2n plus 1 would be what? 0. bn is decreasing, right, to 0. So that implies that S prime is the same as S. So what we have shown is that the limit of the odd partial sums is the same as the limit of the even partial sums. Okay, so that implies that the limit of Sn, okay, even or odd, Sn is going to be the same. We showed that these are both equal to, let's say, S, then the limit of Sn would be S. Okay, so that's why the series is convergent if you assume those two conditions. Am I making sense? All right. The main point, though, is to be able to use the alternating series test. So I'm going to end by one more example, which would be similar to the homework problems that you will be doing. So my last example on this question, let's say I have the series n going from 1 to infinity, negative 1 to the n, ln of n over n. Is this series convergent or divergent? That's the question. In this class, did I give you this question without the negative one? Did I ask you this question in the last exam? Or I had ln in the denominator? Okay, I think I gave this problem in the other section. That ln over n. And without the negative 1 to the n, it turns out that this series is divergent. This series is divergent without the negative 1. So but if I make it alternating, it becomes convergent. Let's see why it is convergent. We're going to use the alternating series test. So again, I am going to call which one bn. This one would be my bn. So let bn be ln of n over n. And I need to show that bn is a decreasing sequence. Now I can show that bn is a decreasing sequence directly, but it is a little trickier. Okay? So you see why? Because if I want to show what is the bn plus 1? Bn plus 1 is ln of n plus 1 divided by n plus 1, and bn is this. Which one is bigger? Because in one of them, the numerator is bigger, in the other one, the denominator is bigger. So it's hard to know exactly which one is bigger. So in this case, I am going to instead look at the function f of x which is ln of x over x, and I'm going to ask myself, for what values of x is this function decreasing? Well, what do I have to do? Find the derivative by applying the quotient rule, and if you apply the quotient rule, do you get this? Remember, that's what we got when we talked about integral test. Now, when is this derivative negative? That's when the function is decreasing, right? So if I want to know when is this derivative negative? Well, this derivative would be negative if what? Well, the denominator is x squared, so that's just positive. So the sign depends on the numerator. So this would be negative if the numerator 1 minus ln of x is what? Negative. And which means that 1 is less than what? 1 is less than ln x, which means ln x is greater than 1. And then what can I say about x? What's that? Greater than e, because ln of e is 1, so when x is bigger than e, ln of x will be bigger than 1. So when x is bigger than e, I have that. So I could say that my function f of x, which is ln x over x, is decreasing on e to infinity. So the sequence Bn, which is ln of n over n, is decreasing for what? N larger or equal to?
Or is it x? Does it matter if x is larger or no? Right above that. Does it matter that it's not equal to?
It doesn't matter. Yeah. Yeah. So I could say that it's decreasing from e to infinity. I can include e because it's a continuous function. So if you say it's decreasing from e to infinity, you can also include e. Okay, so for n greater than or equal to 3, because n has to be larger than e. So I can say that my sequence Bn is decreasing for n bigger than 3. So what I have shown is that ln of n is is a decreasing sequence for n bigger than 3. Do I care what happens for n equals to 1 and n equals to 2? It doesn't matter. As long as the sequence is decreasing after some point 1, we can apply the test. Now, what's the second thing I have to show? The next thing I have to show is what? So this is the first thing. The first thing I have to show is that the sequence is decreasing. Second thing I have to show is that the limit of Bn is what? 0. So what is Bn? So I need to show this is so what's the limit of Bn? That's the same as Bn being ln of n over n. Everybody's okay? How do you show this is what's the limit of this? L'Hopital's rule. Very good. So if I use the L'Hopital's rule, I know that this is the same as the limit. Let me be more proper and convert to x, even though it doesn't really matter. So this is the limit. If I take the derivative, I get 1 over x divided by 1. So here is where I'm applying the L'Hopital's rule. And then this is the limit of 1 over x. Oh, remember that we are looking at the limit as n goes to infinity, right? So here the limit is x goes to infinity. So this is 0. So the limit of Bn is 0 as well. So both conditions are met. So by the alternating series test, the series -1 to the n ln n over n is convergent. Is everybody okay with that? Okay, this is all you need to answer your homework questions, and your homework is the following. Your homework is 3, 5, 9, 11, and 13. 3, 5, 9, 11, and 13. Okay, Wednesday would be my last lecture, okay? And Thursday and Friday we will go over the previous exams or whatever questions you might be having, okay? And discuss about the final exam.